Hi everyone, this is Mrs. Eggerding and we're working on the second video for this unit and we're going to talk about some function operations. The good news about function operations is it's stuff you have done before already, just might be written in a different format. So up in the directions we're defining two functions. F of x is x squared plus 1 and we're going to have a different function. G of x is 3x plus 5. When they want you to find f of x plus g of x, they just want you to add those two polynomials together. So we have x squared plus 1 plus g of x, which is 3x plus 5. Last thing we need to worry about is if there are any like terms. And in this case, we have a plus 1 and a plus 5. So we can combine those together and get a final answer of x squared plus 3x plus 6. Okay. Same thing works with subtraction. We have 3x plus 5 minus, here, parentheses around the entire f of x. That is important. So we're taking all of g of x, subtracting all of f of x. Again, we look for like terms to combine. And so you get 3x minus x squared, and this becomes 5 minus 1, which is a positive 4. And so there's the final answer for subtraction. Another way you might see it written, fg, this is multiplication. So fgx, they want you to multiply x squared plus 1 times 3x plus 5. And now we can distribute these. So we would get 3x to the third. X squared times 5 is 5x squared. Distribute 1 times 3x and the 1 times 5. No like terms to combine, so there is the multiplication. And the last one you could see is division. We wrote this as f of x divided by g of x. So it's going to be x squared plus 1 divided by 3x plus 5. We could do long division to simplify, but we're going to stop right here. The only thing on this one with division, I did create a domain restriction. Now I haven't mentioned anything about the domain on the rest of them because the addition, well, let's start with the original questions. F and G have domains of all real numbers. It's a quadratic and a linear. Domain is all real numbers. When I add, subtract, or multiply those, I create things where the domain is still all real numbers. Division causes problems. Even though by itself each one has a domain of all real numbers, when I create division, I create something where I can't have a 0 in the denominator. And so the domain of this is all real numbers except for x is equal to negative 5/3. That's the value that would make the denominator 0. So when you're doing the function operations, you do have to be careful about any domain restrictions that may end up because of either the original functions or because you did something like division. And we can talk more about that in class. So what about evaluating these? Same two functions, and let's go ahead and evaluate some of these things. First one, f of 1 plus g of 3. F of 1 means I'm going to take the 1 and plug it in for f, and I'm going to add to it what I get by plugging in 3 for g. 1 squared plus 1 is 2. Here this becomes 9 plus 4 is 14. So I get 2 plus 14 is 16. Same thing with subtraction. I'm going to do 3 times negative 6 plus 5. That's the g of negative 6, minus 2 squared plus 1. That's the f of 2. This becomes, let's see, negative 18 plus 5 is negative 13, minus 5. I get negative 18. F times g of negative 1, again, it's multiplication. So I'm going to take negative 1 squared plus 1 times 3 times negative 1 plus 5. Negative 1 squared is 1, plus 1 is 2. Negative 3 plus 5 is 2, so this becomes 2 times 2, or 4. And division, f of 0 divided by g of 0. F of 0 is 0 squared plus 1. G of 0 is 3 times 0 plus 5. That becomes 1/5. Okay, so two types of things. One where you evaluate by plugging in the numbers. The other, you just perform the operations of combining like terms or distributing or dividing. So 1 through 13 odd has you practicing these, and you should be able to do the operations of addition, subtraction, multiplication, and division, but it is all algebraic representations. In other words, we're giving you the formulas, representations. We're giving you the formulas in an algebraic form. Bring your questions to class, and we'll see you in a little bit.